Good evening. In this session, the previous session, we have seen about Ohm's law and a little bit about ohmic and non-ohmic conductors. Now, in this session, we'll see about series and parallel circuits. How are they different, or what are their common properties, and how should you approach while you're solving questions, right? Now, series and parallel, actually, the name itself, from the name itself, you can see that they are parallel to each other. So these are termed as parallel. And here, series, you just have one single loop or one single path for the current to flow through. All right. Now, I notice initially when you start again, some students get confused or they find it difficult to remember which is constant and which is not. Is I constant, is V constant? They will get confused. My tip for you will be, for series, there is only one path flowing through, right? So the current at any point in a series circuit will be constant. I repeat, you can remember it as a loop. Series, you will just have one single loop. Parallel, if you remember parallel, immediately the opposite will have one single circuit or path for the current to flow through. So at any point in a series circuit, the current flow will be constant, or the current will be the same. If you remember that point, the rest you can develop it from there. If the current is same, then what is the other quantity which will change? It will be the voltage. So the voltage will be split, or the potential difference will be split across the components. Okay. So once you get that, so I will be same, V will be split. So if you remember for series, just the opposite will happen in parallel. So what will be the same here? V will be same, I will be split. Right. I've just written it in one term, but then you have, when you're writing, you have to write it in elaborate. The current flow gets divided at junction and so on. Here the current flow will be the same. The voltage will be split between the components across in a series circuit. All right. Okay. Now that's about the properties you should remember. As I said, start from one point, series circuit, I is same, V is split. Just the opposite for parallel. Now the formula. From here, V is equal to, since V is split, V will be equal to V1 plus V2. Okay, if you remember this formula, then immediately you can remember R will be equal to R1 plus R2. So these two are important for solving questions. So you need to remember these two for series. Now in parallel, I will be equal to I1 plus I2, and 1 over R is equal to 1 over R1 plus 1 over R2 plus, if you have more, you just need to keep on adding the number of resistors. Here I've just shown 2, so the formula will stop here. So if you have 3, you keep on adding it. But then there's one alternative formula to remember instead of this, because mostly you will be handling 2 resistors in parallel. As I said, if there are more than 2 resistors, you must continue with the formula with fraction. But if you have 2 resistors, there is a simpler formula. Not only simpler, you will also avoid mistakes. Okay, those of you who have already practiced questions, you may understand. See, when you substitute it here, for say if it is 10 ohms, you're finding the effective resistance, the total resistance here. You may forget to take the inverse at the final step. Okay, when you forget that step, then the rest of the calculations will go wrong. Okay, so instead of using this formula, and remember, if you only have 2 resistors, I would advise you to use the formula R, or R effective will be equal to the product over sum. R1, R2 divided by R1 plus R2. So this formula will be easy because you don't have to take inverse in this case. Do you get it? But if you're using this formula, the final step you have to inverse. One more tip I'll tell you for you is most of the conductors, you will not get the resistance to be in decimal values. If you're doing this calculation, finally you will end up with the decimal value. But remember, normal conductors will have like whole number values only. So if you get a decimal value, please check if it is a resistor, or if you're calculating for a resistor, there might be something wrong in your calculation. Probably you would have forgotten to take the inverse. Check on that, right? Now, having given all the formula, how to approach these questions if they ask any missing value. Right? Here also, I'm not going to solve questions here. I'll only give you some tips. I would advise you to, there are lots of plenty of online resources for worksheets available. Try those questions. But remember the technique or the tip that I'm telling you, it might be handy while you're applying it. Now see, if you're asked to find out voltage across R1 or across this R2 or here, or you may have one more resistor here as R3 and so on. So there might be many complicated questions or circuits that you may have to analyze. So how do you approach all these questions? First point, remember, if you are using the supply voltage, before that, see, all this VIR relation is this formula, correct? You are going to use this formula. You're expected to use this formula to find V or I or R. But then what's the difference is the substitution. The substitution is where you have to be very careful, because that's where most of the students get confused. So when will you go wrong with the substitution? If you're not clear with the concept. All right. Now what's the concept? See, if I'm using the supply voltage, the battery's voltage, into this formula, okay, then I must use, or the current value will be the current supplied by the battery. Now what is that depending on? What current will be supplied by the battery? Will it be constant? This is again a misconception. Students think there's a standard current given by the battery. No, it isn't true. The current supplied by the battery will depend upon how much or what is the total resistance in the external circuit. So if I have more resistance connected here, the overall resistance is more, the current supply will be less. They get it? So when will I get the maximum current? If there is no resistance at all, which will be like if I just connect a wire across the terminals of a battery, if I just take one end to the other end, that will be the maximum current supplied by the battery, which in other words we call it as short circuit. Okay, short circuit means the maximum current that can be drawn from a supply. When will that happen? In the external circuit, if it is, the resistance is 0. Now, so the current supplied by a battery, if you want to find out, then I should use the voltage of the supply and the total resistance in the external circuit. They get it? The total resistance. Why? As I said, the battery's current depends upon the total resistance. So don't make that mistake, because I've seen they just put V is equal to IR, and just randomly if you pick some resistance value and write, will you get the current supplied by the battery? No. Got that? So keep that point. That's point number 1. Point number 2 is that value of current that you find out will be the same for these components. Why? Because you just have only one loop. Correct? So in a series circuit, we have seen at any point you will have the current flow to be the same. So once you figure out a simple calculation, say if it is 6 volt here, if you've got 10 and 10 here, what will be the total resistance? 20. So 6 upon 20, whatever value you're getting, that amperes will be the same at any given point here. Why? Because in a series circuit, the current is the same. You get it? Because sometimes the question is asked, what is the current flow across R1? You do not know what's the voltage here, but it's split equally here, it's easy. But then otherwise, if you are asked some random value is given, you might be wondering, without voltage, how will I calculate? So this is where you have to apply the concept. If I find the current supplied by the battery, that will be the same current through each component. Because that's what I said, substitution is very important. Now here in this case, I have found out the total resistance. I've used this V. I have calculated the current supplied by the battery. Now, from the battery, it will pass through this resistance. Is it split here? No. So, say for example, the current value is 5 ampere supplied by the battery. It will be the same through this. It will be the same through R3 as well. Why? Because there is no branching here. It is like a single loop. Even here, if you have an ammeter, this will also read 5 amperes. So from this point, this loop, this entire part, you will have 5 ampere current flowing. Do you get it? Why? Because there is nothing to or the current is not split till these 2 points. Then what happens? It will get split here. So if it is, we label it as I2 and I1. So this 5 amperes will split between these two resistors. That's why we said here I will be split and V is going to be same. Now how will I find the current flowing through R1 and R2? There are more than one method. Easier method will be if you know this voltage, the voltage divided by the resistance, because you are using it for that particular component's current is what you are calculating. You get it? So if I want to find out the current through R1, I should substitute the value of potential difference across this and the resistance of this particular component. I'll get the current through from where? From this point to this point I will get it. Similarly for R2, if I want to find out, I'll use the same, because V is same across these two resistors, I'll use the same. Okay. If this is not there. Assume this wasn't there, so V will be the same here, and V over R1 will give you I1, V over R2 will give you I2. If you want to check your calculation if that is correct, I1 and I2 should add up to the current supplied by the battery. Clear? So what are the three main points that you will remember? One, the current supplied by the battery depends on the total resistance. The total resistance you have to use, you have to find using those two formula I gave you earlier, R1 plus R2 for series, R1 R2 divided by R1 plus R2 for parallel. Then once you get that, you will get the current supplied by the battery. Now if it is series, all components will have the same current through each one of them. If it is parallel, then it gets split from the junction. Okay, from the junction. Then if you want to calculate each components, you just take V and then divide by the component's resistance. I hope. And one more point to remember, if you want to find a particular component's resistance or current or voltage, you should substitute the values of the component, not the battery. What I mean by is, here I cannot substitute 6 over 10 to get the current flow here. It will be wrong. Why? Because that 10 ohms is for this, and this V will be split. It will not be the same across here. You get it? The 6 volt will be between these 2 points, you will get 6 volt. These 2 points will have 3 because it is 10 and 10. Here also will have 3. Okay, so if you substitute 6 over 10, you will go wrong in this calculation. I hope I will shed some light on to your understanding, and I hope you will not make silly mistakes or these common errors anymore. All the best, and see you in another video. Bye.